just get lost. And now that he has money, it'll turn into an obsession. Or he'll just get a nice niche print.
Okay. So I should start now?
I'll do a brief intro.
Okay.
Got my new. Right. Welcome everyone. We're going to go ahead and get started. If you haven't signed in, please do so. There's a sign-in sheet here. I'll take it to the back, but as most of you know, it just helps us justify the pizza, and we also do being able to pizza. I think that's my announcement for today. So we can go ahead and just speaker. Today's speaker is Jie Song, and she's a grad student in computer science and engineering. She's also currently a database researcher.
Hi everyone. Welcome to my talk today about our project related to continuous capture of metadata. So I'm with the CSE department. I work with Professor Jagadish. This is a 3-year project working with ICPSR of our university. I'm not sure whether you are familiar with ICPSR. It's a data hub for social science data, pretty popular one. And we also work with MDNA, Collectica, and several other groups to make this possible. So talking about data, we know it's a pretty hot topic recently. But before actually using the data for analysis, people collect data, manipulate the data, and do some like adaptations to their own use cases. So the data that helps us to identify the proper data for their use is called the metadata. So the metadata is the data that describes the data. So as many communities are pushing towards like making data published together with their metadata, so there are these efforts try to make this more widely available nowadays. But different communities, they have their own like standards for metadata documentation. For example, social science, we use the DDI format mostly. So it's an XML-based format. And the ecological data, they use EML format, also XML-based. Some other domains, biological data, they have their like formats called Darwin core, and some other general purpose formats such as Dublin core, MOS. Recently, Google has published their like a search engine for data sets. It's called the Google Dataset Search, and they created their own standards called schema.org. So these standards are basically pretty simple. So the standards define the tags. So if you say I include this tag, I will provide some description corresponding to the tag. So I'll show you an example of this metadata standards in DDI format. So this is a snapshot of the data set called world population from 1950 to 1975. And on this page for the data set, we can see the version information. So we don't see actually the data content, right? But we see some other like metadata information. For example, oh, okay, sorry. Oh. The version information, the principal investigator for the data set, and some other information such as this is the project level description. It gives a summary of like who collects the data, what kind of like people are involved in the process, and how to cite the data in a standard format. Other than that, it gives like other metadata information such as documentation level, variable information, and related publication. So and this one, it has like data related publication, only one of them. So one publication has referred to this data set. So all this data, this information, they are called metadata. And the metadata can be exported in some standard format. So this is the metadata of the previous data set in DDI format. So as I said, it's in XML format. So it started with this tag called codebook. This is DDI's name for the metadata documentation. Then it has text such as document description, including the title statement, the product statement, and the copyright information. Other than that, it has the study level description, as what we have seen in the previous page. The title of the data called word population, and some other information related to that. So it's pretty clear. It provides like a user a brief view of what data is about and whether it can be used for your research purpose later. So how are these research data collected? We just target the social science data from ICPSR, and this is the process how they are collected. So they are generally collected through surveys, and the surveys are conducted through computer-assisted interview software called DDI. So they can through your phones, but there's no paper involved in the process. So it's like a questionnaire. So basically, as a recipient of the questionnaire, you are asked a question such as what's your gender, what's your age, and how many people are there in your family if it's for population information question. So those kind of questions are part of the metadata we have seen. It's like they can be listed as the variables in column format in a data table. So as we have seen, the CAI program itself is a questionnaire, and the questionnaire information is the metadata. So if we have this questionnaire, then we'll get a better understanding of data content. Okay. So, let's say we first have the computer assisted interviewing, and the people have answered questionnaires. And what's good about it is that CAI itself, they have the automatic conversion functionality to convert the CAI questionnaire into DDI format. So it automatically creates this metadata information for the data collected. And that's the original data we have. So this is the original data. This is the original metadata in DDI format. But what's next is that, as I have talked about, people may use the original data. That's they want to do some modifications to the original data before they use it. So they will modify the data. So generally, people use some statistical software to do the modifications. They will form the command script in some of the statistical languages. For example, SPSS is a pretty old language, popular in the 1970s. And then more recent ones such as Stats and Stata. The general purpose language are Python, SQL. They are all part of this process. So with this written command script, they are sent together with the original data. They are sent to the statistical packages to do the processing. And then we'll get revised data to do analysis or for downstream applications. But the problem with that is the revised data is no longer matching the original metadata. So the transformation process is not included in the metadata. It's describing the original data rather than the current data. So if we want to publish the revised data, then we need metadata for the revised data rather than the original data. The original data will come as an archive to be published, but it has no question context, no interview flow, no variable province, and the transformations are not documented. So how are we able to include that documentation information, make the revised data to have its own metadata? So what we intend to do is that we'll extract the metadata from the transformation script, and then into the DDI format, and then publish the revised data together with their own metadata. But the problem is that the transformation are documented by hand. So let's say we have the original metadata, and then we have the transformation. In order to get the new metadata, we need to manually include the transformation in the metadata. That's not, so we want to make it automatic, so users don't have to do it manually. Yeah, okay. Okay, so systems themselves will have limited metadata. For example, variable names, labels, value labels, but there's no properties such as how the variable is derived from the original variables. So what variables have influenced the derivation of this new variable. To enable the automatic capture of the metadata, of the transformation metadata, what we want to do is that in an automatic way, we want to create a script parser such that will convert the command script in some of the statistical languages into a standard data transformation language. And then we'll have an updater to embed the transformation information into the original metadata, so that we will derive the updated metadata for the revised data. Do you have any questions up to this point? Okay, so those are the missing links we want to build. First, a converter, a script parser that converts the statistical language to SCPL, and then an updater that embed the transformation information into the original metadata. Okay, so what kind of script parser should we implement? We can't name all of them, but those are the major ones that we choose to do. So we collect the ICPSR dataset download information from year 2015 to 2016. And that's the percentile of the data download by format. So 43% are delimited tests. So those data can be processed by statistical language, whichever user choose. So other than that, SPSS, SAS, Stata, and R, they all compose a large amount of the downloads. So we'll assume that people download data in this format, they will process data with their languages corresponding. So those are the 4 languages we choose to parse and convert as part of the script parser. Sorry. So I'm trying to say the problem why we create the standard data transformation language is that statistical packages, they are disparate. They have different data models, the representation for transformations, and the scopes of transformations covered. So that's why we don't say I choose one of the languages as the standard transformation representation and convert all other languages to this language. So it's not a good selection. Okay, so I will show an example of how they are disparate. So this is an example of 2 scripts, SPSS script and the Stata script. They are doing the same thing. So basically, with the input data set, they try to create a variable called partyCare1 by summing the 3 variables, and then add a variable label to this new variable, do some filtering, and then sort the data set. So these 2 scripts, they are doing the same thing, but their syntax are different. So that's what we call the representation of the transformation are different in these languages. And also, as I have talked about, the scopes of transformation supported are different. So some of the languages, they support pivot transformations, but some others, they don't. And in SQL, for example, in some of the SQL versions, before 2014, they have the pivot function. They don't have the pivot function, but after that, they will have a support for pivot function. So this kind of scope support difference will make it hard for using one of the statistical languages as a standard representation. So that's why we propose a new representation of our own. It's called SDTL, Standard Data Transformation Language. So we'll create a common syntax for the 4 statistical packages. So this package, scripts written in these languages, they can be converted to our language, SDTL. And then SDTL will be embedded into the metadata information. And it has the format like represented in JSON format. So it can be easily reused by other computer applications. So I won't talk like the details of SDTL. It's too specific. So I will just jump to the use case of the system. So then, as we have the standard data transformation language, this workflow has been completed. So this part, we have a command script, and parser will convert it to the transformation language, SDTL. And then the updater will update SDTL representation to the metadata.
Is there any software?
You mean like an executable engine?
Yes.
No, we don't have an executable engine, but we have the functionality to convert SDTL to one of the statistical languages of your choice. So if you really want to process the data in one of the selected languages, we can do that.
If you say you convert the original R script to SDTL and then let's compile it back to R. So is there any numerical difference original and real and transformed R?
So our claim is that we'll ensure the data before and after transformation, the process with the previous language and the new language, they are functionally equivalent. So basically, the table content will be the same. So even though like R from R to SDTL and then back to R, the commands used may be different, but the result you get will be the same. So I won't talk too much details about like how we implement this, but this is the general workflow. So first, given the command script as the input, we'll have a JSON like a script parser as I talked about. The script parser will adopt like will parse the original script into abstract syntax tree. That may be too computer science oriented. Yeah. Yeah. So basically, it will convert it into SDTL. And then we'll have a pseudocode generator that provides a more natural language-like description of what the command does. So even though you don't understand one of the statistical languages, you will get an understanding of what this command is about. And then using the XML updater, we will update the original metadata with SDTL into the new DDI file. So it will more further convert it to the codebook format, as we have seen in the previous example. The command script, we're currently implementing SPS, Stata, SAS, and R. In the past 3 years, we have completed the first 3 ones, and we are working on R, Python, and SQL. And the XML updater, in addition to the DDI format I have talked about, we are also doing it for XML, EML format. So both of them are XML based. They use tags to like identify the metadata information. So instead of the ICPSR codebook format, we are also targeting other codebook formats. That is under development. So here I will show you an example of how this process works. This is a variable called, it refers to the dollar amount of this data set. Aging data in the sense of control. So then we can see it has these values as possible values. And the values will have value labels of frequency, weighted frequency, from the questionnaires and the percentage. So then through some conversion, like transformations we have talked about, it is converted to a categorical variable. So this categorical will like basically form them into different labels, into different groups, and then recompute this like metadata information. The code to do this categorical conversion is like that. This is in SPSS. So basically, it generates a new variable called, well, something, and recode this variable by assigning these values as 1, this value as 2, to different categories. And then we convert it to SDTL. This is the SDTL representation for this command. So it's a command we call compute. The compute will have a target variable, which is the output of the compute. And the expression will have variable name as the input of this compute. There's no condition for this compute. And the command will call recode. So first we'll have a create a variable called this. And then we have a recode transformation. This transformation will take the source variable and the target variable and the recode based on these rules. So SDTI is like an internal representation of the transformation. You don't have to like know or understand it, but we'll convert it into the pseudocode representation. So the pseudocode will say, this is the target variable we have created. It describes the household income groups. And then the derivation process of this variable will be first, we'll set a variable, the name of the variable equal to the variable, the input variable. And then we recode the variables of this variable such that these values are recorded following these rules. So it's easier for you to understand in this natural language like structure as part of the code book. So don't worry about SDTL. Just look at the pseudocode, and that's what we contribute to the metadata description.
Oh, 3, lower bar. So here is 50,000, and the original code is 49,999.
Okay, maybe it's more. Yeah, sorry, some errors. So then after that, we'll update the original metadata with our transformation information. So this is the part that involves our documentation called derivation. So how we derive this variable are encoded in this format. And then after that, it can be converted to HTML format, which is the colorful format used by ICPSR. So in a web page, we will show something like that. So yeah, this is a reinforcement of the pipeline. So then I will show you an example of an actual process for this updater. So this is So this is the dataset updater tool we have used. So the previous link, I showed 2 links in the on the PowerPoint. But the first one, what you do is you upload your original metadata in DDI format. You also upload your script for transformation, and it will return you the updated metadata. But that one is like there's no interaction. You can't see the process. So that's why we use the second link at the MTNA version. It will show you how it works step by step. So first, I'll upload my transformation script. So this file ends with SPS. That means it's written in SPSS language. So it automatically identifies it written in SPSS. If it can tell which language it's written in, then it will ask you to identify yourself. Then, so it first through the parser, it can like tell it has one compute, one reload, one recode, rename, set variable label, and set value label. Those are the commands existing in the script. Is this the only thing? Then it converts it to SDTL in the JSON format. As we have seen, this is the program, the transformation, the program level information. Has ID, the source file name, the source language. Like how many rows are there in the script, some like metadata information about the script itself. And then those commands includes like the transformation actually like processing included in the script. We first have the load information, the load script command.
Can I interrupt for a second? We have a question online.
Okay.
That asked if the script parser can handle custom and/or language-specific functions.
Custom what language?
If you're getting custom and/or language-specific functions.
Andor.
And/or.
No, I think that's not supported for now. So for commands we can do, we will just show command not supported. So it will not like interrupt the conversion process, but just for that script, it will for that command it will show command not supported. And then we have the compute, right, recode. So those commands are in order, and right, that's the original STL. And then we'll upload the original metadata in DDI format. You can fill like additional metadata information as part of the metadata. So this is a new XML format, metadata DDI format we have. Oh, where is it saved? Right, this is in the XML format, and the transformation information are here. Yeah, so previous ones, they are the original metadata of the original data. And this part below are the transformation information for contained in the script. And an updated code book will look like this. It's a HTML page. So those are the metadata format and the variable descriptions before transformation and current variable description. So those after transformation, those are the variables now in the revised data set. It also have these links to like how the current variable are derived from other variables.
Can you click one of those?
I'm not sure whether it's working now. Yeah, it should have this scroll bar and jump to the part, but not working. This is not the online. This one is local, so that's why it's not working.
Yeah. That's why I was confused. Really?
So other than that, we provide some provenance tracking functionalities. So I'm not sure how many of you are familiar with provenance.
I had one question before you moved on. It was just from online.
Okay.
And it said, when converting to JSON, does the process also preserve the original script as well?
We don't preserve the original script, but if you want to, you can easily do that. So here's the thing. So for each command converted, we'll have a JSON property called original command. So it will show the original command in like original language, like SPSS or something, but not in a section of the code. But each command have their own corresponding in the JSON. So yeah, we provide these tracking functionalities for provenance information understanding. So provenance basically give you an idea of how the data are derived, the derivation process of the variable, as I have talked about. Because this one is under maintenance, it's not online, so I just took some snapshots of this tool. So it's a byproduct of our the main tool. So basically, we upload a script to this tracking tool, and then it's able to tell. Well, we provide the nodes are data sets, the round nodes are data sets. And the square brackets are the transformation functions. So basically, we upload 4 data sets, and they are merged together through the append data set operation. And this is the intermediate data set you can derive. And then we do some analysis for this intermediate data set, as well as a computation operation. So deriving another data set. So it goes through this process like a tree-like structure to basically tracking what variables or data sets are derived in this whole command transformation process. And clicking on there's a view table tag and also a view operator tag. So clicking on the round nodes, you will be able to see the content of the data set itself, intermediate data or the original data. And clicking on the operator, here I'll show the original script in SPSS. So this is a command, and then a translation from SPSS to SCTL. This is a corresponding translation. This is a view table. As we have clicked on this, this dataset node, it will show the current content of the dataset. And some other functionality we have provided are sort, filter. The user can get a better understanding of what are actually in this current step dataset. And other than that, we have the tracking functionality. So an interesting question has been studied in computer science is called why and why not problem. So why is like why this tuple appeared in the current step, and why not is that why this tuple doesn't appear in the current step. So it will help you to debug whether you have written a correct like transformation command, or like help you like track how you derive the tuple in this whole transformation process. So to enable that functionality, we have a tracking function provided here. So first you select the tuple you want to track, and also select the tables along which you want to track the tuple. Then the tracking will give you like how the current this variable are processed along this like a transformation command. So this is the mean table here, and we track after this transformation it appears here, and we then track this intermediate table after another transformation. Yeah, so those are basically what we have done so far. And I have talked about, we are still under development, so some of the functionalities are not fully available. But if you want to try out the updater tool, you can try it with SPS and SAS. Those functionalities are available now. Yep. Okay. Any questions? Okay. Yeah, I don't talk much about like the technical difficulties we have encountered in the process of converting between languages, because well, if you really look into that, you will see many of the functions, even though they look the same, like addition, that's a simple function, but different languages they do it differently. And also, for example, SPSS will treat missing values as negative infinity, but SAS will treat it as positive infinity, and some others they will treat it as 0. So you have to deal with all corner cases like that to make sure that before and after conversion, you get the same like data set. So that's what we expected to make sure that the metadata documentation is accurate. Okay.
But if the original data transformation script has logical errors,
We don't like we are not a processor as we talked about. We don't have an engine for processing. So we'll just translate whatever given to us.
then you have the boundary overlaps. Both.
No, we won't do that. So basically, the original script, we just translate what the original script writes. So if the original script has error in it, we are not able to tell there's error.
One of the examples you showed earlier.
Mm-hmm.
So where there are the previous bin and the next bin.
So you mean through the tracking tool? Yeah, the tracking tool will be able to tell that. So it's different. So the updater tool, it doesn't involve the data, but the tracking tool, it involves the data. So actually, the tracking tool is more complex than the updater tool. But right, as you have said, in the tracking tool, if we encounter an error, we will just report it.
Any other questions? Thank you.